Looking at problem number 1, first of all, let's look at the instructions. The instructions say to find the exact value on the interval, and they tell us that angle X is between 0 degrees and 90 degrees inclusive. So that is telling me that my angle X is in which quadrant? Yeah, it's in quadrant 1. So notice with problem number 1, they gave us that tangent of X is equal to 3. And they're asking us to find the cotangent of X. So if the tangent is 3 over 1, cotangent would be the reciprocal. And what would the cotangent of X be? 1/3. Next one, problem number 2, we have sine of X equals 5/13. Cosine of X, that's what we're looking for. Now, are those reciprocals? No. So this one, I'm actually going to have to do some solving. Now, I'm going to show you how I can solve for this using some of our trig identities. So we are dealing with sine and cosine here. And I know an identity with sine and cosine, and that would be sine squared of X plus cosine squared of X is equal to what? 1. Now for sine, they gave me the sine value. They said that the sine was 5/13. And sine needs to be squared. We're solving for cosine, so I'm leaving this as cosine squared, and that equals 1. Now square 5/13, what is 5 squared? 25, and what is 13 squared? 169 plus cosine squared of X. And instead of 1, I'm going to rewrite that as 169 over 169. That way when I subtract 25 out of 169 to both sides, I already have a common denominator. So that gives me cosine squared of X equals, what is 169 minus 25? 144 out of 169. Cosine is squared, so we want just cosine, so take the square root. And that would give us the cosine of X is equal to, and what's the square root of 144 over 169? 12/13. So the cosine of X is 12 out of 13. Now that was the long way to do it. So I showed you that you could use identities to solve these. Or if they tell you specifically in which quadrant your angle is in, you can just draw yourself a picture, right? So they tell me angle X is in quadrant 1. So here's my angle X. They gave me sine, which was opposite over hypotenuse. So the opposite is 5, the hypotenuse is 13, and if you know your Pythagorean triples, what is the adjacent side? 12. And they asked us for the cosine, which would be adjacent over hypotenuse, and that cosine would be 12 out of 13. So do we want to use identities to solve these, or do we just want to use our triangles? Yeah, let's do the triangles. Save ourselves some time and frustration. Next one, number 3, we have cosine of X is 2/3. We're looking for the tangent. So again, let's go ahead and just use triangles to solve this. So draw your triangle in quadrant 1. Here's my angle X. And cosine is adjacent over hypotenuse. So the adjacent side is 2. The hypotenuse is 3. This time we'll actually have to use Pythagorean theorem to find that missing side. So that would be 2 squared plus b squared equals 3 squared. So 4 plus b squared equals 9. And when you subtract 4, b squared is equal to 5. And when we square root that tells us side b is just square root of 5. But they asked us for tangent, and how do you find tangent off of a right triangle? Opposite over adjacent. So what do I put for opposite? square root of 5. What do I put for adjacent? 2. So our answer is square root of 5 over 2. Number 4, they gave us the cosecant is 5 over what? 1. And cosecant is reciprocal for what trig function? Sine. So sine is opposite over hypotenuse. This is hypotenuse over opposite. Draw your triangle. Again, angle X is in quadrant 1. The hypotenuse should be labeled 5. The opposite side should be labeled 1. And again, we'll have to use the Pythagorean theorem to find that adjacent side. So this would be 1 squared plus b squared equals 5 squared. So b squared would be what? 24. And when we square root that, don't leave it as square root of 24. You need to simplify your radicals. So square root of 24 simplifies to? 2. Yeah, 2 square root of 6. And they asked us for not for cosecant, they asked us for secant. And secant is the reciprocal for which trig function? Cosine. So cosine is adjacent over hypotenuse. For the secant, we need hypotenuse over adjacent. So what do I put for the hypotenuse? 5. What do I put for the adjacent side? 2 square root of 6. Don't leave your answer like that. Do rationalize. Now, if you have to multiply by the conjugate, like yesterday, we're not going to rationalize. But if you just have a single square root with nothing added, go ahead and rationalize. So to rationalize that, we need to multiply both the numerator and denominator by square root of 6. So this would be 5 square root of 6 over 12. So make sure your answer is in simplest radical form. Next one, they gave us sine of x is equal to 7 out of 11. I want you to solve number 5. We'll check your answers momentarily. So the opposite side is 7. The hypotenuse is 11. And what did you get for the adjacent side? 6 square root of 2. And where did that come from? That was 7 squared plus b squared equals 11 squared. So 49 plus b squared equals 121. What's 121 minus 49? 72. And that would be 36 times 2, so this would be 6 square root of 2. And they asked us for tangent, and how do you find tangent? Opposite over adjacent. So the opposite side is 7. Adjacent side is 6 square root of 2. This does need to be rationalized because this is not multiplying by a conjugate. And this would be 7 square root of 2 over 12. Okay, now moving on to verifying identity. Some more practice. Now again, when it says to verify, you start with one side and prove that it equals the other side. So I'm going to go left to right. I'm going to start with the left side. So starting with the left side, that's cosine of x over 1 plus sine of x plus cosine of x over 1 minus sine of x. So rewrite the left side. Now when you are subtracting fractions, what do you have to have? Common denominator. And what would the common denominator be here? Yeah, 1 plus sine of x times 1 minus sine of x. Now I know this equals 1 minus sine squared, but hopefully, I'll leave it in factors form that way, hopefully something will cancel. Okay, so the first fraction, it has 1 plus sine of x, what is it missing? 1 minus sine of x, and that has to be multiplied by cosine. That second fraction has 1 minus sine of x, so that means it is missing the 1 plus sine of x. And that one needs to be multiplied by cosine of x. Now go ahead and distribute. So cosine of x times 1 would be cosine of x. Cosine of x times negative sine of x would be negative cosine of x, sine of x. And cosine of x times 1 would be cosine of x, and cosine of x times sine of x would be cosine of x, sine of x. And in the denominator is still 1 plus sine of x, 1 minus sine of x. Now notice when I'm doing my proof, I started with the left side and then I showed what it equals. The next step, I have an equal sign. So make sure you are doing that with each step. And also note, I did the entire expression. I know these two are kind of big, but I'm doing them together. Because what I've been noticing is some of you are doing this over on one side of the page, then you're doing this way over here somewhere else with scratch work, and then you're trying to combine the two and draw arrows, and don't do that. Just go in a linear pattern and make sure these expressions are equal. Okay, so negative cosine x sine of x, positive cosine x sine of x, that makes a zero pair. So that pair makes 0 and goes away. Now, something else I've noticed. We are adding these. This is actually a 1 cosine of x plus 1 cosine of x. If I have 1 cosine plus 1 cosine, how many cosines do I have? 2. So that should be 2 cosine of x. And what I've been noticing is some of you are putting it cosine squared. It's not. So 1 cosine plus 1 cosine is 2 cosines. It is not squared. And in the denominator, am I going to have any factors cancel? No. So I'm going to go ahead and multiply those, and when you multiply those, you get 1 minus sine squared of x. And 1 minus sine squared of x is equal to cosine squared of x. Then what happens? Yeah, cosine of x, one of these in the numerator will cancel, only one in the denominator. So that leaves us with 2 over cosine of x, which is equal to 2 secant of x. So I started with the left side, and I showed equivalent operations to show that it equals the right side. So I start with the left and prove it equals the right. So notice the equal sign, and notice there's a flow to it. Some of you are going all over the page, and I can't follow what you're doing. So make sure it's in a single line or single row somehow. Just show an equal sign where I can see where you're going. Okay, next example, number 7, we have 1 minus cotangent to the 4th power of x. Now, I mentioned earlier this week that if you see a trig that's higher than a power of 2, it probably needs a factor. So let's do this one left to right as well. So let's start with 1 minus cotangent to the 4th power of x. So if it's higher than a square, it probably needs a factor. So how can I factor that?
1 minus cot squared tangent plus cotangent.
Yeah, that's the difference of squares. So we'll have 1 plus cotangent squared of x. And 1 minus cotangent squared of x. If you see 1 and squared trig, what should you be thinking? Yeah, it's probably a Pythagorean identity. So one of these probably is. I don't know if it's the one with the plus or the one with the minus, but let's check it. Now over here, I'm doing scratch work. You can do it wherever you want, but if it's scratch work off to the side and it's not part of the proof, here's where you can abbreviate with the S's and C's. Some of you over here in the actual proof part, you're abbreviating sine with S and cosine with C. Don't do that unless it's scratch work off to the side. So in the actual proof, you need to use SIN and COS. So if I have cotangent squared, what do I have to divide by? Sine squared. So sine squared divided by sine squared would be 1. Cosine squared divided by sine squared would be cotangent squared, and 1 over sine squared would be cosecant squared. So back to my proof, instead of 1 plus cotangent squared, I could replace that with what? Cosecant squared. Now, if I distributed, then I'd have cosecant squared times cotangent squared, but there's actually another trick I could do. Should my answer have a cotangent squared in it? No. So this cotangent squared, if I go back to over here, my scratch work where I left off, solve this for cotangent squared. So I'd have to subtract 1 to both sides. So that gives me cotangent squared equals what? Cosecant squared minus 1. So back to my proof over here, instead of the cotangent squared, I'm going to replace it with cosecant squared minus 1. That way I don't have the cotangent squared anymore. So bring down the cosecant squared of x, bring down the parentheses, bring down the 1, and the minus. Now cotangent squared is going to be replaced with a binomial. So we're going to group that binomial in parentheses, and that would be cosecant squared of x minus 1. So that negative will have to be distributed to the cosecant squared and to the negative 1. So working inside the parentheses, this would be 1 minus cosecant squared of x, and negative 1 times negative 1 would be positive 1. And still working inside the parentheses, break it down to some simple math. 1 plus 1 would be 2 minus cosecant squared of x. Now distribute that cosecant squared. So cosecant squared of x times 2 would be 2 cosecant squared of x. And cosecant squared of x times negative cosecant squared of x will give me negative cosecant to what power? 4th power of x. And we finished that one. We proved the left side equals the right side. And the last one, number 8, let's go left to right again. So we'll start with secant to the 4th power of x minus secant squared of x. Now again, if you see a trig with a power higher than 2, it needs to factor most likely. And I could factor that 2 ways. I could factor that as a difference of squares, but what's the other way I could factor that? Yeah, there's a GCF. Both of those have a secant squared, right? So factor out the GCF. So we're going to factor out a secant squared of x. So what would go in the parentheses? Secant squared of x minus 1. Now I'm looking at the answer. Should I have a secant squared in my answer? No. So I'm going to replace secant squared with something else using a Pythagorean identity. So over here is my scratch word, sine squared plus cosine squared equals 1. And if I want secant squared, what would I have to divide by? Cosine squared. So sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared would be secant squared. So back to my proof, instead of the secant squared, what can I replace those with? So this would be tangent squared of x plus 1. I'll put that in parentheses because that became a binomial. And instead of this secant squared, what do I replace that with? Tangent squared of x plus 1. And behind that secant squared, I need to have a minus 1. And if I simplify, what happens right here? Yeah, positive 1, negative 1, that's a 0 pair, so just drop down your tangent squared. And distribute your tangent squared. So tangent squared of x times tangent squared of x would be tangent to the 4th power of x. And tangent squared times 1. Tangent squared of x. Is that what we wanted for the final answer? No. What did we want in the final answer? 1 over cotangent, and 1 over cotangent is equal to tangent. So I'm basically there. I just have to change this to cotangent. So use the reciprocal. So tangent to the 4th power of x would be 1 over cotangent to the 4th power of x. And instead of tangent squared using the reciprocal, this would be 1 over cotangent squared of x. And I proved that the left side equals the right side. So the only new thing today is if you have a trig function that is squared, you could replace it with an expression from the Pythagorean identity.